welcome to the Mathematician's Podcast, the podcast where we follow the fascinating stories behind the people that count in the history of mathematics. I'm your host, Benjamin Cornish, and today we're drawing a line underneath someone often called the first mathematician, Thales of Miletus. You might find it unusual that this honour goes to someone from episode 2, not episode 1. But hopefully I will be able to convince you that Thales was a true mathematician and not a mere engineer like Ames. My nephew is 7 years old and is making his best effort to find ways to be annoying. Fortunately, as a teacher, I am immune to the weapon that he wields against others. Every time he asks the question, why, it gives me an excuse to educate him. For instance, about how his gut's microbiome will be affected by the addition of broccoli or chocolate, or about the relationship between fast-moving cars and little boys that don't wait for the green man. Fluid dynamics, as we would call that in mathematics. Naturally, when you become a teacher, you are not only a teacher of maths, you are a teacher of everything. However, like in calculus, all good things come to a limit. What I find interesting is to track how many whys it takes before we reach an unanswerable question of psychology, philosophy, or physics. You have to brush your teeth. Well, because otherwise the germs will grow too much and damage them. Or because they like moist, sugary environments and you eat too many sweets. Okay, so it's to do with the way they get their energy. They break up big sugar molecules into smaller ones and use the energy from the breakup to move about. That's because there are attractive forces between atoms, a bit like a load of balls being held together with springs. And if you cut the springs, they'll ping back and that releases energy. The energy, it can't be destroyed, so it has to go somewhere, and it turns into a photon and sort of walks off. Why? Okay, I think that's the bit that a wizard does it. Eventually, the answer is that wizards do it. Sometimes it takes a long time, but sometimes it's magnets. I think wizards do that straight away. Turns out magnets have been fascinating for as long as we've had magnets. And for the most part, the answer has been that they had little gods in them. But for everything else, Thales tried to get a good answer. Now, if you're a maths lover, you've probably used some of his ideas, maybe when discussing geometry or the origins of mathematical reasoning. Although I'd hasten to bet that ordinary folks walk in the footsteps of Thales as well. In my weekend job as an ice cream man, I regularly use data around the weather to determine when I'm likely to make the best sales of ice cream. But who was Thales? What did he actually do? And why should he still matter today? Well, grab your compass and straight edge, because we're about to find out. To understand Thales, we need to go back to the 6th century BCE, to the bustling Ionian city of Miletus, on the western coast of what's now Turkey, a little north of modern-day Didim. Miletus was a hub of trade and culture, a place where ideas from Egypt, Babylon, and the broader Mediterranean world converged. Thales lived in a world where myth and superstition explained much of what people observed. Lightning was Zeus's wrath, and the earth floated on a cosmic ocean. But Thales broke from this tradition. He is one of the first figures in Western history to suggest that natural phenomena could be explained by reason and observation, rather than mythology. Then again, he also believed everything was ultimately made out of water. In terms of mathematics, we already know that it was a thriving industry by this time. Thales is understood to have travelled to Egypt to learn his geometry. From this, it may be fair to assume that he did not discover the mathematics attributed to him, but it is certainly the oldest evidence we have. He is notable for defining a number as a collection of units following the Egyptian view. Make of this quotation what you will. Now, Thales' reputation as a mathematician comes primarily from geometry. The Greek historian Proclus, writing centuries later, credits Thales with several geometric insights. But before we get into specifics, let's address a key question. Did Thales actually prove anything in the way that we think of mathematical proof today? Probably not. Formal proofs were a later Greek innovation. But Thales did something equally revolutionary. He identified patterns and abstracted them into general principles. Here are a few of the theorems attributed to Thales. If a triangle is inscribed in a circle such that one side is the diameter, then the triangle is a right triangle. Picture this. Draw a circle, pick any 2 points on the edge, connect them to form the triangle. If one side is the diameter, the triangle is guaranteed to have a right angle. Thales is said to have demonstrated this by practical means, drawing in the sand, rather than with the rigorous logic we associate with Euclid. Thales is credited with recognizing that in an isosceles triangle, the angles opposite the equal sides are also equal. This observation is fundamental to understanding symmetry, a concept students encounter throughout their maths education. Thales showed that when two straight lines cross, the vertically opposite angles are equal. This theorem is so basic to geometry that we almost take it for granted, but imagine being the first to notice it. Why are these contributions important? For one thing, they illustrate a shift from empirical knowledge, measurement and rules of thumb, to theoretical insight. Thales didn't just know that certain geometric patterns existed, he also sought to understand why. Now, Thales wasn't just a theorist, he was also a practical problem solver. One famous story tells of him determining the height of the Great Pyramid in Egypt. According to Herodotus, Thales waited until the time of day when his shadow was exactly the same length as his own height. At that moment, he measured the shadow of the pyramid and concluded that it must equal its height. This is a wonderful anecdote because it ties abstract mathematical thinking to real-world problem solving. It's also an example of proportional reasoning, a cornerstone of mathematical development. Thales' contributions to mathematics didn't exist in isolation. His work laid the foundations for later Greek mathematicians, most notably Pythagoras, who studied in Miletus and may have been influenced by Thales. Thales' idea that the natural world could be understood through numbers and patterns became fundamental in Western thought. But it's not just mathematicians who owe a debt to Thales. His approach, questioning assumptions, seeking evidence, and building logical systems, is a model of the scientific method. In that sense, he's not just the first mathematician, he's also one of the first scientists. Now, Thales wasn't just a mathematician, he was also one of the first philosophers in the Western tradition. In fact, he's often regarded as the father of philosophy because he sought rational, natural explanations for the world, rather than relying on myths or divine intervention. Thales' key philosophical idea is that water is the fundamental substance of the universe, the ark, or first principle. He proposed that everything in the world could ultimately be traced back to water as its source. At first glance, this might seem naive, but it's revolutionary for two reasons. Thales might have chosen water because he observed its versatility. It can exist as a liquid, a solid, ice, or a gas, steam. In other words, water could change its forms, but remain fundamentally the same, which aligned with his belief in a unified substance underlying all things. Thales' claim makes a shift from mythological thinking to naturalistic inquiry. He wasn't saying that a god created everything from water, he was saying that water itself was the basis of all matter. This was one of the earliest attempts to explain the diversity of nature through a single, unifying principle, a precursor to what we now think of as scientific models. For me, this raises an even more interesting question for my students, or at least for those who have expressed religious leanings. did God create mathematics? Better yet, could she have created it differently? These are questions that helped with my own transition away from organised religion. In modern terms, we might say that Thales was grappling with ideas about matter, states of matter, and conservation, concepts that remain central to physics and chemistry today. Now, Thales didn't stop at abstract philosophy. Some sources suggest he applied his rational mindset to early studies of physical phenomena. Thales is credited with predicting a solar eclipse, likely the one that occurred in 585 BCE. While it's unclear how accurate this claim is, it demonstrated that Thales viewed celestial events as predictable and governed by natural law, rather than as random acts of God. One of the most famous anecdotes about Thales comes from Aristotle, who tells the story of how Thales used his knowledge of astronomy and weather patterns to predict a particularly bountiful oil harvest. To capitalise on this, Thales rented all the olive presses in Miletus and nearby regions during the off-season, when demand was low. When harvest time arrived and the presses were in high demand, he leased them out at a premium, making a significant profit. Aristotle used this story to illustrate that philosophers, though often uninterested in wealth, could achieve it if they desired. For teachers, this tale is a fantastic example of how mathematical reasoning, scientific observation, and practical application can intersect, demonstrating to students the value of knowledge in solving real-world problems and even entrepreneurial ventures. It also points the finger at Thales as the father of economics, in the classic buy low, sell high school of thought. By my counting, he is now the father of 3 or 4 disciplines. He's certainly got around. Thales reportedly observed that amber, when rubbed, could attract small objects like straw, a phenomenon we now recognise as static electricity. He also noted the properties of magnetite, a naturally occurring magnetic material. These observations drew people towards studies in electromagnetism. Some accounts describe Thales devising practical tools based on his observations of physics. For example, he may have used basic principles of leverage and buoyancy in problem solving, such as aiding sailors or engineers in Miletus. Thales himself left no writings that have survived. In fact, it's unclear if he wrote anything at all. Most of what we know comes from later authors who compiled and interpreted earlier traditions. Herodotus, often called the father of history, is one of our earliest sources mentioning Thales, around 484 to 425 BCE. He credits Thales with engineering feats, such as advising how to divert a river for military purposes, and also mentions Thales' prediction of the eclipse. Herodotus' accounts are generally historical, though they sometimes veer into legend. Aristotle, around 384 to 322 BCE, is one of the most significant sources on Thales. In his work Metaphysics and Politics, Aristotle discusses Thales' philosophical ideas, particularly his assertion that water is the fundamental substance of the universe. Aristotle also shares anecdotes, like the olive press story, to illustrate Thales' practical wisdom and to frame him as a thinker focused on natural rather than supernatural explanations. Diogenes Laertius wrote Lives and Opinions of Eminent Philosophers, a biographical collection that includes a chapter on Thales. He provides a mix of biographical details, philosophical contributions, and colourful anecdotes, some likely drawn from earlier sources like Aristotle and Herodotus, and others possibly invented or exaggerated. Proclus, in the 5th century CE, a commentator on Euclid's Elements, credits Thales with foundational contributions to geometry. He discussed Thales' theorem and his role in introducing geometric ideas to Greece, likely influenced by Egyptian and Babylonian mathematics. Other writers, such as Plutarch and Strabo, and even later historians on science, also reference Thales, often drawing on the works of Aristotle and earlier traditions. Despite the challenges, there's a broad consensus among ancient writers about Thales' importance as a mathematician, philosopher, and early scientist. While specific details may be exaggerated or romanticised, the recurring themes, his focus on natural explanations, his geometric insights, and his practical ingenuity, are likely rooted in historical reality. For educators, this serves as a great reminder of how history, even of mathematics, is pieced together through a mix of evidence, inference, and interpretation. It's an opportunity to discuss with students how our understanding of the past is shaped and why it's important to critically evaluate our sources. In our last episode, where we met Ames, we had the delight of a surviving manuscript. For this, we thank the pioneering work of the Egyptians for writing on papyrus and preserving it in dry, dark conditions. However, outside of a desert crypt, or on less durable material, complex works on mathematics are harder to find. We do have a good record of clay tablets written in cuneiform from Mesopotamia, but this was largely focused on accounting and meteorological data. Some interesting features are the sexagesimal system, that is base 60, and the depiction of Pythagorean triples, some 1,000 years before Pythagoras. But I mentioned the lack of evidence of early maths to put into context this period of discovery, in that there was plenty of maths about, we just don't know who did it first. So when I compile this list of mathematicians, I will be led by what work survives and whose name we know, or at least the names that other ancient historians thought they knew. In the end, whether Thales really existed or not, whether he discovered the concepts attributed to him or not, is somewhat inconsequential. At this stage in history, the line between truth and myth is somewhat blurred. And for us, well, we're telling a story of ourselves and how we came to this point in mathematics. Does it matter whether that story is entirely true? Ames was a bit of an anomaly in the Euro-Mediterranean tradition of maths, in that his work is extant, that is, it still survives. But we will not see another extant works until we meet Euclid around 300 BCE. For this reason, I will be grouping together this first batch of mathematicians as the pre-Euclideans, who largely share the same historical sources as our dear Thales. In later episodes, I hope to be able to introduce you to more historical evidence when we can eventually find some. So why should a maths teacher care about a man who lived 2,500 years ago? Well, firstly, Thales' work reminds us that mathematics is fundamentally about curiosity. When we teach, we're not just imparting knowledge, we're helping students develop the tools to ask big questions about the world. But I like Thales as the man to grab the low-hanging fruit. Sure, if it wasn't him, someone else would have noticed that vertically opposite angles are equal, although this fact does elude many of my own students. But sometimes something being obvious means that people will miss it. Without these obvious steps taken, the rest of the mathematical project of humanity would have stalled. Sometimes we simply have to state the obvious. Moreover, I like to encourage my students to continue looking for the low-hanging fruit. There is a tendency to assume that all the easy jobs have been done, and that development and progress only ever gets harder. But if history can teach us anything, it's that there's always a really obvious thing still yet unsaid. What would have happened if we all gave up after Thales, because now we know how to find the height of the pyramid? Secondly, Thales' blend of abstract reasoning and practical application is a great example for students who struggle to see the point of maths. His method shows that the same principles that govern the geometry of a triangle can help solve real-world problems, like measuring a pyramid or building a bridge. Finally, sharing Thales' story helps humanize mathematics. When students learn that maths didn't emerge fully formed, but was shaped by curious, inventive people, they can see themselves as part of that ongoing story. As teachers, connecting mathematics to philosophy and physics can give students a broader understanding of how knowledge develops. Thales exemplifies interdisciplinary thinking. He used observations of the physical world to inform his mathematical ideas, and vice versa. One humorous anecdote, also shared by Aristotle, tells of Thales walking at night, gazing intently at the stars, when he fell into a well. A passing Thracian servant girl laughed and teased him, saying he was so focused on the heavens that he couldn't see what was in front of his feet. This story is often interpreted as a gentle critique of philosophers who may overlook everyday concerns in their pursuit of lofty truths. For teachers, it's a great way to remind students that balance between theoretical thinking and practical awareness is key. The stories of Thales' philosophical insights help us to see that the study of mathematics and science isn't just about solving problems. It's about grappling with fundamental questions. Why does the world behave the way it does? How can we find unity in complexity? Thales' belief in the predictability of nature is a message of empowerment for us all. If we observe carefully and think logically, we too can uncover patterns and principles that explain the world. And that's all for today's episode of the Mathematicians podcast. I hope you have enjoyed this pressing tale of Thales of Miletus. Join me next week, where we will be exploring Pythagoras of Samos. Yes, that one. You would be irrational to miss it. Until then, goodbye. The music today is Danse, Macabre, Finale by Kevin MacLeod. You can find more information in the show notes.